Hi dear friend, my name is SMA and you are watching Civil Engineering Discoveries. Dear friend, today we will discuss about bearing, that how we can find fore bearing and back bearing, and also we will find the departure and latitude. So these are the traverse data which internal angle are given. So the included angle A, included angle B, included angle C, included angle T and E and M. So these are the internal angles. So the length for AB has given that are 17.098 and ABC, CD and so on. So these are the length. So bearing of AF is given, which has 136 degree 25 minute and 12 seconds. So the bearing of AF is given only and the other bearing is unknown. So you will find the bearing. The departure is unknown and latitude is also unknown, so we will find the departure and latitude. So the adjustment of angular error, the summation of included angle is equal to we will add the included angle A, B, C and D, so that will be the summation of included angle. Theoretical sum of included angle is equal to 2n minus 4 multiplied by 90. So n has the number of internal angle that how many internal angle are given. So that will be the n. So there are 6. So we will write in the n. So 2 multiplied by 6 minus 4 multiplied by 90. So the theoretical sum of included angle is equal to 720 degree. Total error will be the summation of included angle minus theoretical sum of included angle, so that will be the total correction. So plus 12 is the total correction. So we will subtract 12 inch from all the internal angle, included angle ABC, so that will be the 6. So we will subtract minus 2. So the corrected included angle will be included angle A 130 degree 18 minute and 45 inch minus 2, so that will be the corrected angle. So included angle B, so the corrected angle will be 110 degree and 18 minute and 21 second. So included angle C and D and E and F, so these are the corrected included angle. So calculation of bearing. So the fore bearing of FA is equal to back bearing of AF. So the back bearing is given above in the question, so that will be the fore bearing for FA 136 degree 25 minute and 12 inch. So the fore bearing of AB is equal to back bearing of A plus included angle. So we will use this formula for all the back bearing and fore bearing of included angle AB and BC and CD and so on. So the back bearing of AB is equal to fore bearing of AB minus 180. So these are the north, south, east and west. Now first quadrant has NE and second quadrant has south, east and southwest and fourth quadrant has NW. So 90 N has 0, so the whole circle will be 90 and 180 and 290 and 360. So the first quadrant has from northeast, so that will be from 0 to 90, and the second has from 90 to 180, and the third quadrant will be from SW will be from 180 to 270, and the fourth quadrant from WN will be from 270 to 360. When the value of fore bearing or came in the first quadrant and second quadrant, third quadrant and fourth quadrant, so we will use this formula. For first quadrant has whole circle bearing, and from third quadrant second quadrant will be 180 minus whole circle bearing, and for third will we use this formula, and for fourth quadrant we will use this formula. So the back bearing of AF is AB is equal to 86 degree 43 minute and 55 second. So we will use this formula for all the fore bearing and back bearing. So these are the fore bearing and back bearing. the back bearing of CD is equal to pore bearing of CD plus 180. So the pore bearing of DE and the back bearing of DE, and the pore bearing of EF and the back bearing of EF. So these are the pore bearing and back bearing. So now you will find the departure and latitude. So in the first column, this is station number, which is A, B, C, D, E and F. So the length are given, so you will write for station A, B, C and D and so on. So these are the lengths. And the internal angle are given above in the question, and which we will write here in the internal column. And the correction to each angles which has -2, so we will write here. And the corrected angle will be, so we subtract -2 from these internal angles, so the corrected angle will be for A, B, C. So these are the corrected angles. So we find the bearing above, so we will write here per the station A, B, C and so on. So these are the bearing. So for latitude and departure, we will use this formula. Latitude is equal to LAB cos theta and departure is equal to LAB sin theta. So when the value of departure came in the N in quadrant, so we will use plus for the data one, and we have the value came in the N quadrant of the latitude, so we will use a plus sign for that bearing. So if the value came in the S quadrant, so we will use for departure and latitude plus minus, and SW minus minus, and for NW minus plus. So these are the rule for the departure and latitude. So for the first one, for the departure, LAB sin theta. So LAB has the length of AB, which has 17.098, and the sin and the theta is bearing, so which has 266 degree 43 minute and 55 second. So the departure will be -17.070. So same we will use this formula LAB cos theta. So LAB has length of station A 17.098 and theta has the bearing for station A is 266 degree 43 minute and 55 second. So the value for latitude will be -0.975. So the value came in the which quadrants we use this sign only. So for the same station A, B, so the departure will be LAB sin theta, and so the latitude will be LAB cos theta. So we will use this method for all the departure and latitude. If the value came in the N quadrant, so for the departure we will use the plus sign, and if the latitude came in the N so we will use the plus sign. Same for the latitude. So these are the rules, and so the departure and latitude will be. So these are the departure and latitude of station A, B, C, D, E and F.